All right, so today in the statistics unit, we're going to look at histograms. It also says we'll look at bar charts as well. So bar charts are generally, they look similar to histograms, but we see like a gap in between them. And they're generally, you see something else. So it might be, you see like we might have surveyed to see what type of pets people have, and you might have the number up here, and so you have cat, dog, and bird, whatever. So a bar chart has these gaps in between. If we look at a histogram looks at numerical continuous data. So you can see that's here. So we're getting a category. So I think this histogram shows the birth weights of 100 new babies born at that, how many babies weighed 8 pounds. So we'll have a look. So in this histogram over here, we've drawn a histogram. So you can see it's like a bar chart, but there's no gaps in between. So with this, if you look, how many babies were born between 8 pound or more? Well, here's 8 pounds, so 8 pound or more would be here. Now, if you look at a histogram, they tell you the frequency. So if I measure across here, this one looks like it was 22 high. This one looks like it is 16 high, and this next one looks like 6 high, and this one's 1. So if I want to know how many more were 8 pounds or more, I'd have to add up all those columns like that. So you're going to today be creating histograms. So what you're going to do is you're going to take your frequency table here, and you are going to change it into, or convert this data into a histogram. So what you need to do is your intervals, so these were all the numbers, these were the number of students and their scores for the test, okay? So if you look, this was how many students scored between 76 and 80, so we counted them up and we had 8. So you can see when I draw this histogram, this tower goes up to, this is the frequency here, and it goes up to 8. Now if you look down at the between 96 and 100, there was 2, so you can see this column goes up to 2. So that's how you draw a histogram. You draw the category, you put the intervals down here, spaced out. Here's all the intervals, and then you draw like a tower or a column up to the frequency. So depending on how big your frequency is will depend on your scale. Now you're going to make sure you use a ruler when you're lining and drawing all these. Okay, so let's do a little example one here. So we've got use the data to create a histogram. So all the numbers between 0 and 20. So if I just go through 17, 19, 13, they are between here, 1, 2, 3. So is 7, so 4, so is 14, 5. Now a 27, that's up here. So 27, 57 is in this category, 69 there, 79 is in that one, 77 and 86. So then I just quickly tally them up, 5, 1, 1, 3 and 1. And then here, over here, you can see I've ruled up my 2 scales. Along here will be my intervals. So you can see I've got 0 to 20 here, 20 to 40 there. And here's my frequency along here. So my first column was up to 5 between 0. So I'll draw a box like that. Between 20 and 40 it was 1, 40 and 61, 60 and 80 was 3. So I grow up to there, and 80 and 100 was 1. So you might just do a quick shade with your pencil like that, just so the columns stand out a little bit more, and that's what you're doing. Okay, yeah. So So what you're actually doing today is application, and it's a worksheet. So if you go onto the table I've emailed you, you can click on and you can get to the worksheet. So this is the first question. So I'm going to go through it with you. So we will start off with a square has a side length of X centimeters. Even if they don't ask you to draw diagrams, it's most likely a diagram will be helpful in an application question. So here I'm going to draw what they told me. Now they told me it was a square. So I'm going to indicate like that. What do I mean where I've put those lines there? What does that mean, Baxter? Can you tell me? When I put those black lines on my square there, what does that tell me?
That they have the same length.
Excellent. So, yeah, really good. So that means they have the same length. And sometimes that will just then trigger you to know, well, if that's X, that's X, that's X, and that's X. So it can make it a lot easier. And you'll be surprised by just drawing the diagram, that thought might come to your head and you'll be able to continue on a bit quicker. So it says write an expression for perimeter. So really, first of all, what does perimeter mean? If we've got to find the perimeter, what do I need to find? Someone tell me. I'm going to go Patrick Carmichael.
The length of all the sides combined.
Good. So, could you offer a suggestion? What would an expression for perimeter of this square be?
Would it be like 4x?
Yep, excellent. Well done. So here, Patrick knew that the perimeter was you add all of them up. So I could add them all up, but a nice neater term would just be to say 4x. So when I just say it as 4x, that's like an expression. Now it says find an expression for the area. So who can tell me the area of a square? How do we find, what's the rule for that? Max, are you there?
Yeah, length times width.
Yeah, good. You could say length times width, but in a square, the lengths are the same, aren't they? So we could say it's length times length. Yeah? And do you know what's another way of saying something times something itself? Could I write that as, pardon? What did you say? Yeah, excellent. Well done. Sorry, I just didn't hear you. I thought you said it. Yeah, so there we go. We could write an expression for area. We can just write, now I'm not going to write L squared. What will I write for this example? Because we're not calling, we're calling it X, so we'll call it X squared. Good work. Now, if its side length is increased by Y, write an expression for its new side length. So at the moment, my side length was X. If you're going to increase something, increase means you're adding. So now I've got X plus Y. Okay, now it says write an expression for the new perimeter. Well, you knew the perimeter was 4 times the side length. So I'm going to say 4 times X plus Y. Now we could write it like that, or we could write it expanded out like that. It doesn't really matter which way, because they're not really saying how they want it, if they want it expanded, so either would be correct there. Now it says calculate the perimeter if when X equals 5 and Y equals 9. Well, I'm going to just go here. So we know that the perimeter, we've found a formula, we've said it's 4X plus 4Y. So all I'm going to do is substitute in those values. Y is 9 and X was 5. So 4 times 5 is 20 and 4 times 9 is 36. So I add them together. Now they did say centimeters, so I'll add them together and I write 56 centimeters is my answer. Then it says write an expression for the new expanded area. Well, we said that it was X squared, but now we've got X plus Y. That's the length. So it'd be x plus y squared. Now remember, that means x plus y times x plus y. That's another way to write that. Now, you could leave it like that, but remember we've done expansion patterns, haven't we? Yeah, I'm pretty sure we have. So I'm going to ask Jack, can you expand these brackets out, this one here, but use the expansion pattern? Remember that we said a plus b squared always equals a squared plus 2ab plus b squared. Okay, so what would it be?
Wouldn't it be x squared plus xy?
2xy.
Yeah, 2xy, sorry.
Yep, good.
Then it would go, you go y, 2yx, would it be?
No, so I'm just following the pattern that I wrote up the top there. So you square the first term, x squared. You times two of the other terms together. So times x and y together, we get xy. Times it by 2, you get 2xy. And then I square the last term, so it'll be y squared.
Oh, okay, yeah, sorry. I got a little bit mixed up there.
Yeah. So that could be a quick way. So these are both expressions. But I'm just showing you, because you guys have done expansion patterns, how you could have quickly done that. It doesn't matter which one though, they haven't really said that. Oh no, they did say expand, didn't they? Sorry, they did. So this would have to be the answer there. All right, and then it just says calculate the area when x equals and y equals. So when you go to, sorry, I'll change this to a colour. When we go to calculate the area, we'll just substitute that in. So you can do this on your calculator. So it would be 2 times 3.2 times 4.6 plus y squared, which is 4.6 squared. So you can do that on your calculator and get the answer. Okay, so just be careful. Remember to write the units correctly.